This video is on sets and probability. So this first lot of information here is just prior knowledge information that should have been covered previously to this video, but if not, then just have a bit of a read through it yourself, pause the video, have a read, take any notes you need, and then I'll get into some of the actual content. First of all, just going to do a bit of a review on some of the theoretical and experimental probability. Remember, theoretical is just based on information you've been given, where experimental probability is based on trials that have happened previously and probabilities created from that. First example, find the probability of each event and decide which event is least likely. So throw a factor of 24 on a four-sided dice. So on a four-sided dice, you'd have sides 1, 2, 3 and 4, which are all factors of 24. So for this first one, the probability of T would just be 1, because it's going to happen no matter what. So for the event O, throw a prime on an 8-sided dice. So we have to think about an 8-sided dice, numbered 1 to 8. What are the prime numbers in that? Which would be 2, 3, 5 and 7, which means there are 4 prime numbers on an 8-sided dice, so the probability of this occurring would be 4 over 8, which we then would need to simplify to a half, or you could write it as 0.5. Next one, throw at least 11 on a 12-sided dice, so that's throwing an 11 or a 12, so there's only 2 options for that, which means the probability of this occurring is 2 out of 12 because it's a 12-sided dice, which equals 1 over 6. Next, throw at most 3 on a 6-sided dice, which means we are looking for a 1, 2 or a 3, which is 3 out of 6, so a half again, or 0.5. Throw a multiple of 5 on a 20-sided dice. So multiples of 5 on a 20-sided dice are 5, 10, 15 and 20, which means we would have 4 out of 20, which simplified is 1 out of 5. Now, which event is least likely, which means we are looking for the lowest number. So obviously it's not going to be 1. Then we've got 0.5, 1 over 6 and 1 over 5. So obviously the halves are bigger than 1 over 6 and 1 over 5, and then 1 over 5 is bigger than 1 over 6, so the least likely would be the probability of D happening. Next example, a fair coin is flipped 14 times. Predict the number of times you expect a head to be face up. So we've got 14 trials, and times you'd expect a head to be faced up. It's a fair coin, which means a head is 0.5 or a half. So to work this out, we just have to do 14 times a half, which would equal 7. So you would expect 7 times to get ahead. This is the number of trials times the probability. B, statistical data built up over 5 years shows that the probability of a student being absent at a school is 0.05. There are 531 students in the school. Predict the number of students you expect to be absent at any given day and interpret your answer. This is an example of experimental probability because it's based on data that has been collected, whereas part A would be theoretical because we're just using the idea it's a fair coin. We don't have any previous trials to have a different probability. B, predict the number of students you expect to be absent. So there's 531 students and the probability of being absent is 0.05, which would give us an answer of 26.55. With this, though, we would need to round the answer because we can't have 0.55 of a person. So we will need to make it 27 students. And in C, state the assumptions supporting your answer for part B. So one of the assumptions here needs to be that the absences in all days are equally likely. So there isn't one day that's more likely for somebody to be absent. Example 3, a coastal town carries out a survey of tourists in July 2018. The accommodation type chosen and the age of the tourist are recorded. The information is given in the table below. A tourist is chosen at random from the survey to receive a promotional offer. Determine what age group the tourist is most likely to belong to. So the easiest way to work this out is to look at totals. So if we total all the ages, we would get 305, 529, 286 and 210. So obviously from that we can see that it is more than likely to be somebody within the age group of 31 to 50 because that's where the most people are. Part B, find the probability that the tourist chosen belongs to this age group, expressing your answer as a decimal. All we need to do is our total of 529 divided by our overall total. So if you add all these numbers up, you will get 1,330. Now it says to express your answer as a decimal, so you just need to put that in your calculator and you'll get 0.398, three significant figures. C. In July 2019, 16,000 tourists are predicted to visit the town. If the town's hotels have a capacity for 5,000, predict if the town has enough hotel capacity to meet the demand. Now it says the town's hotels, which means we need to know how many hotels we have, so we need to total that column, which will give us 370. Firstly then we need to work out the probability of a hotel, which would be 370 out of the 1,330 were in a hotel, which equals 0.278. Now that's the probability of people using hotels, and then we've got 16,000 tourists are predicted, which means we then need to multiply that probability by the 16,000, which will give us 4,451, which means we can predict that the town does have enough in the hotel capacity because it is less than 5,000. And that is our introduction to probability.